Greetings and salutations. Welcome back to 1 Lesson 3 Math. The learning objective of this video is to be able to find sides of similar shapes. And we've got an exam question taken from an IGCSE extended paper, and it involves two solids which look a bit like mushrooms, which are mathematically similar. The largest solid has a volume of 64 centimeters cubed. The smaller solid has a volume of 8 centimeters cubed and a height of 5 centimeters. And you have to work out the height of the largest solid. So if you want to have a go at this question, please pause your video now and then I will go through the solutions. So whenever you've got these similar shapes, you might have to find a volume, you might have to find a surface area, or you might have to find a length. In this case, we have to find the height of the smaller mushroom solid, whatever it is. Now, you always have to set up your ratios. So we're going to set up the length ratio, the area ratio, and the volume ratio. Now, this question doesn't actually involve area, but it's always a good idea to have this approach so that we can do it as best as possible in all future questions. So we look at which pair of values we have for the two shapes. We have the volume. The bigger shape is 64 centimeters cubed. The smaller shape is 8 centimeters cubed. So we're going to write these as a volume. Ratio. So we have 64 to 8. Now, one thing that you need to note about your volume ratio is you can only simplify it to a length ratio when they are cube numbers. Now, in this case, they are. So we can find the cube root of 64 and the cube root of 8 to set up our length ratio. So our length ratio is going to be 4 to 2. Now this ratio simplifies to 2 to 1. So we've got a length ratio now, and we can use this length ratio to find the height of the bigger mushroom. So the smaller one is 1 part, and if 1 part is 5, then 2 parts are going to equal 2 times 5, so that the bigger mushroom is going to be 10 centimeters tall. Now, just to note at this point as well, as is always the case in maths, you may be able to find some other ways of doing it, and indeed you could have simplified the volume ratio first. So that volume ratio, if we divided by 8, we would have had 8 to 1, and if we'd cube rooted that, we would have got 2 to 1, because the cube root of 8 is 2, and the cube root of 1 is still 1. So then what we can do with that, if we needed to find the area ratio, we could square it. So to go from length ratio to area ratio, we would square it, and we would have an area ratio of 4 to 1. So anyway, bear that in mind for future questions. I hope this video was helpful. Plenty more on the way. Hasta la pizza, arrivederci, so long, goodbye. We'll see you next time.